So I forgot to turn on the recording piece, but here's what I got so far. The Morse code, I guess, is the name of the kata here. And what it says is basically we need to take a Morse code string, which is consistent of, dots and dashes. So with this example, A is dot dash, and then Q would be dash dash dot dash, and so on and so forth. There's digits as well, and in this case, the message "Hey Jude" would read like this, right? So here's an important bit. Extra spaces before or after the code have no meaning and should be ignored. There is, let me see where it was, the other one, here. It is case insensitive, and traditionally capital letters are used. When the message is in code, a single space is used to separate the character codes, and then 3 spaces are used to separate words. I think other relevant things here. This is more like a context, more like a framework upon which you can understand better what the idea is. But I don't think we need most of that there. And then the idea, well, is to decode basically, right? So they provide for different languages tables or dictionaries that you can use, and in our case, JavaScript will be Morse code for a particular code that we can then turn into an ASCII alphanumeric alphanumeric value, right? And yeah, this is fairly straightforward. I'm sorry that I didn't record the way I was thinking before, but this is it. Mainly, I went and made some notes first. So it is case insensitive. It is single space separating characters, and then 3 will separate the words, and then any extra space at the beginning or end of the string has no meaning. So this part will be important. Let's do that like so. Right on. So Morse code is our entry, which is here, and then we can take the extra spaces are not important part here, and then the 3 spaces separate words will belong here, right? Let's add a little bit of formatting, I guess. I don't know. All right. And then this part is not particularly useful or important in our quick exercise here, so we'll leave it. We will leave it at that. And then single space separates characters. This is important. And we will use it somewhere over here. Over here. Right? So it's either here or here. The reason I have 2 pieces of code is that I was toying with it a little bit, and you wouldn't get the explanation real time, I guess. But so here's the first solution I came up with, and I already formatted as best as I could. So what we take is the words that we got from here, and you remember that the 3 spaces would separate the word. So this means that at this point we have an array of words, basically. That's why I call that variable words. And then what we want to do here is go through each one of those, and then basically decode that particular word. And in my first attempt, what I did was, okay, so I take the word and I split it by a space, because we know that single spaces are what create the separation between characters, right? So every time we get a space, that's when we end up with a new character. So that will get us a new array, and that array needs to be decoded, right? Each element of that array is the actual character that we care for. So we want to decode that, and that's what we are returning from this arrow function here, from this map, right? Once that happened, once we decoded, this will look a little bit more like, and we're doing, so the Morse code here object or dictionary or hash map, basically a JavaScript object, will give us back, in the example that we're looking at right now is HEY, well, not the example, but the test that we have. And we have that, but then we also have something like this, if I'm not mistaken at this point. So J U D E or something, right? So what we need to do here is then take the arrays in there. This is why I am calling them word array. And we are basically attempting to remove the, not remove, but to create a string out of it. And the way we do that is by using the join, and then we join them together without any space, any special character or anything. We're just creating a word here. And at that point, we will get an array that looks like this. So it will say, hey Jude, in this form here. So hey Jude, right? So now we have two arrays. Oh wait, no. This is already joined, right? So this is going to be a single string. And at this point, what we can do is join this array again. And it's just going to say, hey, Jude, and problem solved. So if I save this file or solution and look at the solution here, it says, oh, rest at join is not a function. Wait, yeah, because I already joined it there. So let's remove that. Yeah, I already joined it here, right? So, yeah. Okay, and it works with this. So that made me think that I could probably do something in the lines of using a reduce, which is a little bit more elegant, I guess, if you can call it that. It makes the code, I don't know if it makes it more performant or anything, but I think it makes it more understandable if we take care of reading what it's in here, right? So we're doing basically the same thing. Let's do this. We're basically doing the same thing, right? So we are at one point getting this array, which is going to be within here. Okay, so let me try again. So we're trying to reduce the array we got from words. Sorry, I got distracted a little bit. So we're going to reduce the array we got from words here. And what we're doing is we're eventually going to get res, or a result, let's call it a different thing so we don't get confused by it. So let's do da da da. Let's do final array, right? So this final array will be starting as an empty one, and every time we have a callback for reduce, we need to add a return. What do we call these? These are statements. Sorry, it's a little bit late over here. So this statement will then fill in this part here, which is, you know, our kind of accumulator, if you want to call it that. Cool. So now that we have that, and we can go through this part here. So each word, this is the one that's gonna be my new element in the iteration. This word then is the one that I can split. So if you take a look here, this is basically what we're doing, the same idea. And once we get there, we can now actually parse the Morse code, or we can, you know, decode it. So this could very well be called decoded, and this one will have to be decoded, right? So the decoded will be a word that the final array will be getting. So we are at this point getting this part. So okay, so word we are splitting, and then we are parsing or decoding each character, and then that will render something like, let's see if I'm not wrong here. So this, yeah, will be getting us just the one array per iteration, right? So instead of, you know, going through the whole thing and then through it again and then trying to join it, what we're doing is just going through each of these and then joining them. And then we are just getting, hey, we are getting an actual word, if I am not mistaken. And then that will in turn create this array where eventually it will say, hey, in all caps, hey, and then Jude. This will be the final output, I guess, because we are pushing each and every word into that, and then we're getting hey, and then Jude, and so on and so forth. And then this is the final array that we're getting. So let's try this, and it should fail. I'm gonna save. Yeah, because we're now getting hey and Jude as elements of an array, which is not what we actually wanted. And we can finally either do it here or here. It really depends on our preference. So let's do it here. Oh, come on. Let's do it here, and let's just join it. If I save, that's oh, sorry, by a space, because we need to join them here, right? So that should work as well. And I would argue that this code is a little bit more simple to follow, given that the person reading it knows how reduce works. That's the only kind of gotcha here. Whereas using like a map once and over again and so on and so forth, it kind of would be more would be easier for people to follow in the case that they don't really know what reduce does. But anyway, so let's now try and see if our solution actually, yeah, it does. Yeah, it does work. So let's just call this alternative solution without reducing. So we are just mapping and then using the reducer, right? So, yep, I think that's it. So attempt once more, make sure everything passed, and submit now. All right, let's see. Ah, nice. Okay, so they wrapped the actual decoding into a function, and this will be called within here and here, right? So what's interesting here is that they are making functions that act as units. So they are making sure that one function does one thing. In this case, it will decode by letter, and in this case, it will decode by word, which is pretty cool. This is a very nice solution. I like it. So in this case, what we do is, if we are looking at it the way it executes, we would see that we go to Morse code first, which is our input, and then we trim it as we did in our example or in our solution. Then we seek for the words. So this is basically doing the same thing as we did. And then what's interesting, what's cool, is that we are mapping now the word first, which in turn will be decoding letter by letter, right? So when we enter here, we are going to go through the different words that this array gave us. And then we split those by their space, which means we now get the character map, or sorry, the character array based on this map function. And once we decode the letter, which is basically doing this part, then we can join again the array into a single string that will be returned. And then we have an array of strings that then we join. So it's effectively an array of words that then we can join by a space. Very, very cool. I like this approach. You could probably have saved the decode Morse letter function and just call this. But if you think about testing, for example, and you wanted to make sure that this this part of decoding, which is core to the entire solution, actually worked, then you can test this, right? So you could make sure that all your values in your object are appropriate or match the actual keys that you have, and vice versa, right? So that's one important piece there, to have like a function instead of calling directly this part. Very nice. I like it. All right. What else do we have here? This is a very clever solution as well. So we trim and we split. I haven't seen this before. So we split by a regular expression. Oh, yeah. This is nice. So we split by the 3 spaces or the space. It doesn't matter. That will give us the entire array in just one level, I guess. And what we do then is decode that, and if we can't find it, then that's a word. I would say that's what's happening. I would need to run through that a little bit with more care, but I think that's what's happening. I like it. This is clever, whereas this is very, software crafting oriented, which I also liked. Nice. So some other solutions here. They actually run through the entire. Yeah, I think they didn't use the provided object to their solution. Very cool. So yeah, there's some other solutions in here, but I don't want to take much more of your time. Thanks for watching again, and catch you on the next attempt to solve one of these katas.